All right, CJ, so what do you have for us today?
Well, we just have a couple of the sample parts that are available in CAM samples. And I'm just going to run through turning toolpaths top to bottom and also do milling toolpaths along the way. So obviously the Formula SAE hub here has lots of milling features that'll be good for demonstrating how to do mill turn operations. And these other turning parts have plenty of turning features on them. We'll start with the 2-axis turning because we can run through all the parameters there. But um, yeah, hopefully people have lots of questions along the way because I want to get distracted.
Yeah, I'm seeing some questions already pop in. I'll keep an eye on those. Mainly are on 4 axis. So let me read through that question. In the meantime, let's take us through the first turning part, CJ.
Okay, great. So these CAM samples already have setups in them. All I've done is I've deleted the operations that were there so it can start fresh. But the first turning toolpath that we'll do is turning face. And so to get to the turning operations, I go to the turning tab in manufacture and click the turning drop down, and there's turning face. And there's some really nice options for parametric toolpathing in here. Uh, First thing I want to point out is if I could get to click on there we go. Multiple passes. So this is a neat feature because based on how you set up the stock for the setup, it will calculate the number of passes that it needs for you automatically. So you can see if I put in a step over of 50 thousandths, let me select the tool here. Change your view a bit. You can see we get 2 passes there, and that's just based off of the stock. So if I go into the setup here, I believe I can say that the stock is a fixed size cylinder length. So I make it a little longer and offset this by, let's say, 1/2 inch instead. When I recalculate that toolpath, it gives me the proper number of steps. Right, so that's nice. And we'll change that back to 100 thousandths.
It's probably worth pointing out that yellow box that you're seeing is a preview of the current state of the stock.
Right, yeah. So when you click on a turning operation, it gives you a quick calculation of the preview of all your operations. So you could click one by one on each operation and it shows you the combined result. Okay. Is there anything else about? Yeah, okay. So this is another feature that has been requested for a long time and we finally got it in a while back. But when you are facing the front of a part when you're turning, uh, inserts have a corner radius on them, and if you just go up to 0 on the x-axis, it'll leave just the tip of that corner radius in there where it's spinning around the axis. So you can specify an additional distance so that the tool will go past center and make a completely flat front. And this is a good place to use an expression, or you could say tool corner radius, just like on one of the last hangouts that we did with adaptive clearing. You could say tool corner radius. And you can see on the preview already, the toolpath goes past center. And if you wanted to specify a little bit more, you could. So you could write the formula to be plus another 5 thousandths. All right, and that'll clean it up real nicely. This parameter is also available in the profile roughing, finishing, and also the grooving operation too. So that's a nice addition.
Just as a reminder, while CJ's going through this, the intention for today was to walk through some of the basics of turning. And we'll get deeper as well. But as he hits on things, let's use the chat. Let us know if there's questions, if you want us to dive deeper as he goes past it.
Yeah, please make comments, ask questions. A relatively new change in Fusion Turning is that we separated the turning profile operation into roughing and finishing. And this does a couple of nice things where you can select different tools, you can have different parameters. Okay. And one thing I would like to cover later is how to set up inside profiling or boring. It seems to be a common hang up for a lot of new users. So I'll draw something up that makes it easy to demonstrate that. Okay. What else do we have here? Tangential extension. That's another really nice feature. So let's set up something nice so I can demonstrate tangential extension. So the turning profile toolpath will apply a roughing strategy from front to back. So these preview planes that you see. If I click OK now with the defaults, I get something that looks like that. If I go in and edit, I can specify the back to just go up to a selection, which will be this face for now. Okay, so it's just going to be this front area. And one common thing that turning programmers like to do is extend the ends of the toolpath so that you're coming, when you enter the part, you're coming off that tangent line, and when you're coming off of the part, same thing. So if I want to add front tangential extension, I can do that. So I'll add in a 1/4 inch, and you can see it extends all of those passes by a 1/4 inch, where in contrast, let's duplicate this toolpath just to see the difference. If instead of tangential extension, I added a 1/4 inch to the front offset, I get that, right? So it's trying to rough all the area where it thinks they're stock. So again, the difference there is that this is tangential extension. This is offsetting the plane that controls where the toolpath is looking to cut material.
CJ, is probably worth, and this is a good example, it's probably worth for a moment drawing up some geometry where the tangential extension would intersect with other geometry, just to show how there is some intelligence to it as well, to appropriately trim the toolpath. So partly something like a step on it and a chamfer generally is how I would show it. Yeah, exactly.
Yeah, so
this is going to make sense in a moment here, guys, but a chamfer is oftentimes a place where you want to extend the geometry to get a nice, clean, crisp edge, but in doing that, you could run into the rest of your model, and we want to make sure we preserve your intent of extending it, but don't gouge your part.
Yeah, so this is an exaggerated model just to demonstrate the tangential extension there. So Z. All right, let's do profile finishing just to go one pass. Okay, so I'm going to do this from front to selection, and the selection is going to be that edge. And if I don't apply any offset or any tangential extension, maybe it's a little tough to see there. That's the result. I
just add a roughing toolpath just so we're not confused by the extra.
Yeah, I agree. Profile roughing. Just get rid of that one.
Now, let's rough that to the end of the part too, CJ, because I don't think you hit on that, but I think it's important to think about Fusion in the sense that it is a parametric solution. I think most of you on the call know that. But the way the turning works is you're associatively defining the area in which you want to turn, very similar to 3D where you're setting a containment boundary. So by default, we're going to machine the whole part, and then we're using the geometry tab to contain the area of the part that you want to turn. So can you just show how you extended or contained it, or explain that just a little bit more this time?
Yeah, I guess I went over it too fast there. The defaults are from model front to model back. And so it's going to rough all the material that it can find from front to back. In this case, there's just a small amount of material on the outermost diameter. So there's only one pass, but you can see there's lots of passes in there. And then I can go in and add any offset or anything like that off the front of there. But I'm going to add in the finishing toolpath we were just mentioning.
Sorry, CJ, can you just go back to that that last operation just quickly? I think there's something worth pointing out. So if you look at the geometry tab, this is very similar to the heights tab in milling. But the front containment area of the toolpath is associated from model front. But just click that drop down for a second. And we can see you could say, I want to be from my origin or from the front of the stock instead of the front of the model. A few associative selections here to define intent. If we go to the back side, this is probably where it's going to be more important, where you could see yourself saying, I want to be from the chuck front, quarter inch ahead of the chuck front. So regardless of where the model is, even if you put it further in where the chuck is defined, we're going to stop before you get that. Or in the case that CJ used, a selection. But I think it's important to think through, how do you define your intent so that when a change happens, you still end up with a toolpath that's not going to have a drastic
right. I'm glad you pointed out the chuck front one. In order to use chuck front, you have to make sure that the chuck location is set up correctly in the setup, or else it's not going to be helpful. But when you have the chuck modeled maybe and you select that as a body, it knows that the most positive Z face on the chuck is the chuck front, which is, it's pretty cool.
Does that make sense to everybody on the call? I know there's quite a few people on the call, so I want to make sure that makes sense, and if it's a distraction or not worth us digging into, I'll get a sense of the level of understanding of the people currently on the call.
I could set that up in one of the other ones that has a chuck modeled. That's pretty easy.
That'd be good. Okay, so back to tangential extension. Sorry for your distraction there, CJ.
Yeah, no problem. Okay, so we've roughed that part out. Let's do a profile finishing toolpath. So this is basically the same toolpath, but for finishing passes rather than setting up all of the roughing passes. So again, for geometry, the defaults are front to back. So if I click OK now, it's going to give me one pass from front to back. And I just want to limit it to this chamfer right here. And then we're going to show how tangential extension will avoid gouging the model.
And while you're doing that, this is just another point for generally across Fusion as a CAM system, but most specifically with turning in 3D. The best thing you can do is make as few selections as possible, have the system calculate a toolpath for you, and then start to refine the toolpath. So just like what CJ did, throw the toolpath on it, machine the whole part, and then start to constrain it. It's a little less applicable in 2D where you have to pick geometry or it's really geometry driven, but still even there, I'd strongly recommend folks get a toolpath first and then modify from there instead of setting 1,000 options right at the beginning.
Right. So now I've got my single pass and I want to extend this up. This is with 0 tangential extension. So now I will go back to the geometry tab, and on the back, I'm going to add, let's say, first 1/4 inch of tangential extension, and this still should not collide, which it doesn't. It just extends that and back up there.
Which, by the way, is a best practice when you're turning something on a lathe. There's lots of different reasons why you could end up with just a tiny little bit of a radius because the tool didn't go the whole way up to the edge. So extending past means you're going to get a crisp edge. It's a great best practice for machining.
Yep, exactly. And if I make this huge, like let's make this 3 inches and see what we get. Okay, so now that it's 3 inches, you can see it goes all the way up to this face, but it crawls back up the model there. You know, instead of hiding that, I'm going to run simulation. There, you can see the toolpath pretty clearly there, that it runs up the chamfer, goes as far as it can with the extension until it hits the model, and then it continues with the extension where it's allowed to go.
Yeah.
So that's
and I think that sort of ties back into the initial point that I was making, that the hardest thing for people transitioning from a non-parametric solution to a parametric solution is, as you're using Fusion, whether it's for design or toolpathing, you want to be thinking about what's my intent and how do I get the software to capture my intent so that when I make a change, this other decision I already made is going to update accordingly. And so your intent would have never been, or very unlikely been, to extend the toolpath 1/4 inch so it gouges the part, but maybe that face moved. And this would be a good thing to show CJ. Have it extend 1/2 inch maybe. So it makes it almost to that other face. And then later do a model change that brings that face forward. You wouldn't want to have to wonder if one of your toolpaths is gouging. You want to make sure your intent is preserved. Yeah, you wanted to machine past the edge, but you were never telling the software you wanted to gouge. And so we need to make sure we're doing that. And it's different, and it requires us to build CAM a little bit differently in the case of a parametric solution, because the model can change, and we do want a predictable output that still gets you a good result. So again, there we go. We're at a good example here, where we've now extended out. Where in one model instance, quarter inch was fine, but in the next one it's not fine, and you still want to make sure you don't crash the machine in the process.
Yeah, in fact, on this one, the extension is coming out from the end of this face, but it goes past the end of the stock, so it gets automatically trimmed, because not because it's hitting the model, but because there's no stock.
It's because it's air cutting, which the 2D toolpaths do as well. Incidentally, when you turn on stock contours, which I think CJ showed a couple weeks ago. So CJ, a couple questions, and this is good. We're starting to create a dialogue and an inspiration, and so I'll give the benefit to the people that ask the questions. That's why you're here live and not watching the recording. Two things for you to cover. First, can you explain the contact point and the similarity to contact point boundary in 3D machining? This is something that we updated recently to give you a lot more control in turning. But there's several options on how the containment boundary works. So you've set a boundary, but now do you want it to go to the edge of the tool or to the contact point? And I'll just have CJ kind of explain the differences, because I think that's what the question is.
I'm going to rearrange this drawing a little bit because it's a good part to demonstrate contact point boundary on.
Yep.
All right, regenerate these toolpaths. Okay, and for this toolpath, I'm going to set the tangential extension back to 0. And I'm going to leave it on the so we see this tool limit combo box here that says contact point. I'll get to that in just a second. But what I want to show here...
Do me a favor and just exaggerate the tip radius of that tool. I think it's going to help this.
Yeah, okay. It's a good idea. Okay, insert corner radius. Let's make it... that's probably too big.
I don't think it's too big. We're exaggerating it for the purpose of the presentation.
Yeah. Okay. So one little trick that I'm doing here is using the simulate points to click on. So you can click on points on the toolpath and the tool will jump to that area. And it's red right now because I'm simulating just the finishing toolpath, and it thinks it's colliding with a bunch of stock that's not actually there.
Which, by the way, if you haven't noticed this before, down in the simulation, you can actually see the red marks where the collision first took place as well, and jump to those. Total aside, yeah. But pro tip.
Okay, so you can see that when I click on this endpoint of the cutting pass, the tool is going up to the tangential point. It's touching up to that point, right? Where if I change, right? So I look at my my front and my back containment, and right now we're on contact point. The other option, and this is a really great tooltip, is cutting edge limit. So what we're saying right now with the front and back containment is that these are the faces that the tool needs to touch. If I change this over to cutting edge, what this is saying is that these are the areas where the tool needs to stay inside of. So now when I simulate this toolpath and click on this point, what you'll see is the tool goes up to that plane.
There is a caveat, and the same caveat exists in 3D. It's containing the toolpath to that plane. It's not actually containing the linking move to that plane. So it's just a reminder. We are still gouge checking against the model, but this is containing the toolpath cutting motion.
Yep, that's something to be aware of. But yeah, if you need more clarity on the tool limit option there, this tooltip is actually really good. Was this Mike Matera that did this one?
Mike Matera is doing most of the tooltips now. It was a total aside. I'm not sure anybody cares about this, but when I first was introduced to HSM, I joined the team doing the documentation and tooltips. So a lot of the early 2-axis milling ones were me, but yeah, mainly Mike Matera now.
Awesome. Well, since you mentioned the leads, I think we should talk a little bit about how you can control the leads, because that is also something that we've
Yeah, so
changed.
let's do the controlling leads. I want to make sure before you get to the end of the presentation, there's an ask about face grooving and kind of working through that. But based on where you're at now in the demo, I think it would make sense to explain through how we've changed some of the lead control and what control you have there. But let's just make sure we hit on face grooving if that's okay.
Yeah, no problem. And what I'm going to do here is I'm going to make this wireframe so that we should be able to see the toolpath through the part. Oh, actually, well, gives us the.
I've got another pro tip for you. We can actually use section views inside the CAM space now, and they're quite well suited for turning. So
That's right.
maybe we should use a section view.
Yeah, so if you go to Utilities, Inspect, you can add a section analysis. I'll have to scroll out here, but you select the plane. In this case, this plane is split in half apart. Click OK, and now I have a section view. So if you were doing toolpaths that were internal, like a boring toolpath, you would be able to see the toolpath through the part, which is something that for a while we weren't doing quite correctly. So anyway, looking at the leads here, I'm going to extend the leads. So I'll make them, let's say, 1/4 inch so that we can see them. And right now the leads, you can see, are coming off the front and the back there at an angle that looks like it's relative to just that pass. And the way we are controlling that is on the linking tab, we have a checkbox, or so I thought. Oh, I think it might only be an option in roughing. So on profile finishing, where you have one pass, the angle is always relative to the entry and exit. Right. So if you want a 0 degree lead in and lead out, you get something like that, which that one seemed to have gone up to the boundary.
Yeah.
And retracted off. But this is a 0 degree lead in. And then similarly, if I put in 90 degrees, comes in at a 90 degree angle for the lead in and lead out. And if I look at the roughing toolpath, I'm hoping I'm not crazy here. There are no lead settings, and that's because there are no lead settings for the CAN cycles. So if you check use CAN cycle, you can use CAN cycles, which the CAN cycles on the machines will handle all of the leads and things like that.
Okay, a couple other questions, so I think we should hit on them anyway. Can you try and add a face groove to this and work through putting a toolpath on it? And I'm going to take a look at these questions again. Make sure there's nothing else.
Okay, so face grooving. So I'm going to use the turning groove toolpath, and I will make a grooving tool. That's a milling tool. Okay, insert type, turning grooving. We're going to make this square. And all of these settings are probably fine, just to demonstrate. Okay, so there's our tool. It's pretty thin, but that's all right. Geometry, front to back, that's fine. On the front, I do want to go past here by the corner radius, so I'll just type in tool corner radius. Okay. Passes. So right now, let's see. Roughing passes full step down. This should give us something relatively close to what we want. Okay, looks pretty close there, but it didn't do the front area here, right? We don't have rest machining turned on or anything like that for this toolpath, so it should have picked up that area, and you can see if I click on the preview there and suppress these ones. So if I click on this area, you can sort of see a light area with the stock preview where it didn't cut. In order to get that area to work, you have to offset the front by at least the width of the grooving tool. So if I pull this out here and just to demonstrate, now it's going to do that full area, right? Kind of regardless of where the stock is at this point. So what you can do is you can say stock front and leave, I think, is it insert width? Yeah. If you put in the insert width.
Hey, CJ, there's some different people on the call today. So can you show what you did with those expressions again?
Oh, yeah. So the goal here was to extend out the front plane enough that there's room for the grooving tool to go in there, right? But not so much that I have to ref all that, right? I only need to go the width of the tool. And to be honest, when I made that tool, I just hit OK, and I didn't even pay attention to what the size of the tool was. So for this offset distance from the stock front, I need that to be the tool width. Instead of typing in the number for what the tool width is, I can just type in the expression tool insert width, which is the parameter name for the width of that insert. And I don't even have to know what it is. And it's parametric. I can go into the tool library and change it.
What you're seeing here is as you become thoughtful about your intent, it becomes second nature. So CJ just did that without thinking, because for him, using a parametric solution, he's constantly thinking about what's my intent here. And the one option, if you're not thinking associatively, you'll say, I'm going to type in 1/8 of an inch because it's an 1/8 inch tool. But CJ's thinking, I've got an intent. It needs to go beyond by the thickness of my cutter. Yeah, I know it's an 1/8 of an inch, but what happens when that tool breaks and I need to grab another tool and I use a 3/16 tool? Then you have to go back through and put every spot where you put 1/8 of an inch, you need to replace it. Whereas his muscle memory is, I'm going to link it to the correct value so that my intent is preserved when another change takes place.
Exactly. And now that I've put that expression in there, it just goes the distance that it needs to in order to fit the tool.
And I think the additional thing is, like in some cases or other systems, you might say, I'm going to go to plus 1/4 inch, but then later your change might be that I'm changing from my datum being at the front of my material to being at the back of my material in the front of the face chuck, the face of the chuck. I didn't speak right today. The intent of moving past the front of the model by the thickness of the tool means you can make a bunch of different changes and your intent is preserved. So I think it's extremely important to constantly be thinking about, how am I capturing my intent with any decision you're making. You can't always, but we're trying to build a system that allows you to capture your intent as much as possible.
Yeah, and speaking about intent, I want to make sure that I understood the intent of the question correctly, because the viewer said face grooving.
Yeah, so I was about to tell you that you're covering some good stuff, so I let you. But honestly, you did radial groove, and I believe we wanted to see a face groove on that. So,
well, do they mean that they want the grooving tool turned 90 degrees so that they're axially grooving on the part?
I would imagine you've got an O-ring. Let's pretend you've got a large O-ring on that vertical face that's cut in. So go back to that same part, and I can kind of.
I'm just going to draw a new one with a groove in it.
That's fine too. Yep. If this is wrong, then I'm misunderstanding the question as well. But I believe this is what they want to see.
Yeah, so something like that.
Yeah.
Okay. So the first part of this magic trick is to make sure that your tool is turned 90 degrees, or else it's not going to work at all. Go ahead and make our setup here. All right. So we are doing a turning groove toolpath. I'm going to select a tool, and in this case, I'm going to make a new turning tool with a grooving tool that is turned 90 degrees. So make this turning grooving. Okay. And on the setup tab, we have this orientation and turret setting. And the way you're looking down on this tool preview is as if it were a tool in a tool room lathe. So you're not looking at the tool like it's in a slanted bed turret or something like that, where the insert would be upside down if it were a right-handed cutter. So in this case, I want the tool facing this direction because the part would be on the left. So that's exactly what I want. Okay, click OK. And then turn my outside
I believe you want
grooving.
to set the direction.
Direction.
Oh, no.
Front to back should work. I think we used to have an option in there. Maybe that was on face profile. Anyway, front to back here will be the same kind of containment, but I'm going to select the bottom of that groove. You don't really have to do that step, but I'm doing that to make sure I'm containing it the way I want to. For these settings, we're saying that the inner radius is going to be, I got to move my little preview of Al there. That is going to be the inside. The outer radius, I'm going to select the outer face of that groove. And let's just generate this toolpath and see what we get. And let's also do a section view. Okay, so there's our face grooving toolpath.
You are going to see a large number of crashes, and this incidentally has to do with the fact that the holder, in this case the holder, actually needs to be kind of cup shaped to avoid a crash.
Yeah.
So unfortunately that's a reality of the current situation.
But anyway, the tool goes in and will rough groove. Like Alison just said, it thinks it's crashing because of the holder is square. But you can see it does all of the roughing, and it will do a finish pass from, what do we call it? Is it down only? There's a good tooltip for this.
Yeah. So up, down, just hover for a second. So this is a good best practice, again, from a machining perspective. You don't want to take a long tool like this and drag it up. So you can see this only down option means that when it does the finish pass, it'll come down and then come meet in the middle and then do the same thing from the other side. So only down would be preferred especially on a tool like this.
Right. So let's do this. Let's leave it at up, down, and turn off roughing passes so we can see just the finish pass. Do a simulation on this, turn off the stock. There, and you could see the point, it actually pulled away from the part. It didn't finish this wall right here on the outside. It went down, over, and then retracted. So I would think if we do down only that it would do both sides. We'll change that to only down. And it didn't. I wonder why that is. Maybe because it didn't leave room with the radii. So for the outer radius, let's
go to your passes tab. Do you have a stock to leave turned on?
That's a great question. I do not.
No. It's always fun doing these live webinars where I get to stump CJ.
Yeah, stump the jump. But I like these moments because, okay, so I've got a result now. But these moments show how to get around something that, users otherwise would have thought, hey, that should just work. Sometimes it takes a little bit of, there we go. So I added a little bit of outer radius offset so that the tool had somewhere to go. I wonder how much it actually takes in order to get that section to.
You know what? I'd love for you to dive into this, but I think there's a couple other things we want to talk about, and we're getting close to the end of the 20 minutes. So,
Yeah.
first thing, I'm gonna tee it up of a question, and then I want to make sure we didn't miss other things. But there's a question in regards to tool holder geometry. I
Mhm.
think we covered this on a previous webinar in regards to milling, but the reality is today, all of our holders are defined using parameters. We don't have modeled where you can actually use the modeling commands to create holders. It's something that we're aware of. CJ's actually a product manager for Tool Library and is very aware of it. But again, the reality is today that doesn't happen.
Yeah, but there is a plan to be able to import 3D holders or model your own holders and apply those to tools for simulation.
Maybe I'll rephrase it and say we're very aware of it. And I answered by saying today we're publicly traded, so we can't make commitments on dates.
Right.
But we're very aware of the problem. Okay. So next question that you kind of sparked, so I'm going to have you hit on this. And then if there's not more questions regarding turning, we might take a tangent and do some 4-axis surfacing, because you do a lot of 4-axis machining on a lathe, and maybe start with the 3+2 and then move on to the 4-axis.
Yeah.
There was a question in regards to figuring out what the different parameters were when you did that equation earlier.
Mm-hmm.
So maybe show the autocomplete, and then also specifically the question was, how do you find out what parameters are available from the tool library? And maybe this is a good chance to show how to turn the new tool library experience on and see how those parameters are a little bit more available. Is that fair, CJ?
Yeah, actually in the tool library preview, I don't know if we're showing the parameters yet.
Okay, so at least show the autocomplete then.
Yeah, we can actually show them in the current tool library. That's in there too. But yes, the autocomplete. So when you edit expression and you're showing this window, you don't get autocomplete in the text boxes, but you do get autocomplete in the expression window. So you kind of have to know what you want to start with. But if I type in, tool, if you just type in T, you won't get anything. But the next letter I add for TO, for tool, I start getting suggestions. And this is everything that's available. So if it's not here,
you can't access it.
Then it probably doesn't exist.
Yeah. So hopefully it was a fairly short answer to your question, but hopefully that makes sense. Total aside, while we're on the topic, this is using JavaScript, so any sort of JavaScript math you can do, you can enter in here to calculate your solution.
Yeah, and it's not just tool parameters. So if I type in, like if I wanted to reference the back, so if I type in back, it will give me the absolute values of the back heights and things like that. So there's ways that you can drive it off of other parameters in the operation, not just tool parameters.
Very good. Okay, let me take a moment, just scan the questions in relationship to turning. There's lots of great comments coming in, so I want to make sure we didn't miss anything. We've got some thank yous for face grooving. Did you have any turning stuff you wanted to touch on, CJ, before we kind of move to some of the milling sorts of things you might do on either a lathe or a machine with a rotary axis?
Well, there's lots of turning things.
There's lots of turning things.
I guess one last party trick we can show before we move on to mill turn is in a turning part operation.
That's a party trick. My son would say that's a dad joke.
So I'm going to set this grooving tool back to standard orientation. All right, so on the parting toolpath, we have on the geometry tab this edge break option, and this is pretty cool. So a lot of lathe programmers want to put a little chamfer or radius on the back of the part when it gets parted off. And before, there wasn't really an easy way to do this because you have to groove with the tool before the tool has room to chamfer or fillet a feature on the back of the part and then go the rest of the way. So you kind of had to make 3 operations in order to do that. Now you can just do all 3 of those steps by turning on this checkbox. So if I want a 50 thou chamfer on the back of the part, now what it's going to do is it's going to plunge as far as the tool needs to in order to make room then do the chamfer, then part the rest of the way through. This is obviously not a long enough tool, but that's a pretty cool
And
thing.
in this case, I believe your outer, it's going to make the chamfer based on the outer diameter. So that's why it's chamfering the stock, because his associative
Correct.
OD was set to stock diameter, is my
Yeah.
assumption.
So instead of the outer radius being stock OD, I could say model OD. Now it properly chamfers the part instead of just the outer diameter of the
Yeah,
stock.
but again, that's where the intent is captured. It did what it should. So just take a minute. I know somebody on the chat was mentioning that the face grooving wasn't acting the way it should. So I think just first make as few changes as possible as you're working through the problem, and then just remember the software is trying to capture intent. And so in some cases, that direct control you had over a non-associative system makes some things easier to do, but means that you don't get predictable results. So that is the balance.
Yeah, and if that viewer is still having issues with their face grooving operation, they can post that on the forum, and I'll take a look at it.
Yep, and that was already mentioned by one of the users. Go to the forums. A great option.
Awesome. Okay, so Milton.
I see a couple questions here first, CJ.
Yeah, okay, great.
Plans in regarding to add section analysis to stock simulation. It's something I've personally noticed. I can't talk to plans, but yeah, we're aware of the problem. And if you're wondering who I am, by the way, I didn't introduce myself. CJ and I are product managers, and specifically, I lead all the product managers that are responsible for CAM software at Autodesk. So hopefully that helps. And what's the green icon on the nav bar down at the bottom, CJ?
Oh, this one right here? Can I give a shameless plug to Patrick Rainsbury?
You can give a shameless plug to Patrick Rainsbury.
Okay. So we have an Autodesker that has written some nice add-ins for Fusion. And this particular add-in is called Fusion Sheeter. And it uses Google Sheets to create effectively configurations. So I don't have any configurations in this document, but let's say that you had a part that had, it was the same base part, but it had varying dimensions. You could create a Google Sheet that had all of those dimensions for the different styles of the part, and you can call them up here, and it'll change all the dimensions and parameters. I think it also does display states and things
So
like
instead
that.
of talking deep into this particular add-in, the point is it's an add-in. So can you do me a favor and go to the add-ins library? Because I think this is one of the under-realized aspects of Fusion. And again, this is a total tangent right now.
Yeah.
But go to the web and see, instead of looking here, actually, I'd rather you just go to the web page and show people how to get more. There's some great ones.
Oh, you won't be able to see my web screen because it's just showing Fusion.
Oh, well, so my recommendation is just show where you went their add-ins, CJ. Add-ins App Store. I just noticed an add-in the other day. Somebody created, I think they charged $6 or $7 for it. An add-in that will allow you to use a CNC machine with a drag knife, and it works with a dozen different post processors to extend the tool path. So there's all kinds of interesting add-ins that are done, and I think you should certainly encourage people to take a look at that, because it may open your mind to the kinds of things that can be done on top of the software by folks other than Autodesk. Again, sorry for the tangent, but it's one of those rabbit holes that I don't think everybody knows they can go down.
Yeah. Awesome. So milling toolpaths. If you're doing mill turn operations, there's nothing that you have to do differently per se to use milling operations. As long as you use the compatible post, it'll automatically configure all the points and things like that to use live tools and things like that on your mill turn machine. So just to demonstrate that, first I'll add a turning roughing toolpath to rough out this part. Just use the default settings. Okay, so we get a toolpath that will rough out this part. And then let's say that we wanted to use...
Just show that angle for a minute. I keep distracting you, but show that the toolpath on the back. People might be wondering why. That long angle is maintaining the clearance on the back side of the holder. If you're wondering why why that toolpath may look quote unquote funny. If you didn't want that to happen, how would you stop it?
Oh, well, let's use tangential extension.
And then my other thing is like, what if I didn't want it to gouge into the part at all?
Yeah, so if you don't want it to gouge into part at all, on the passes tab, there's this grooving option. Right now it says allow radial grooving, so it will allow the tool to go up and back in. So I think in terms of can cycles, this is like monotonic versus non-monotonic. So this is, yeah, sorry. But basically, if you say don't allow grooving, those of you who know what that meant, this basically turns it into a non-monotonic roughing strategy, and it won't try to dip back into the part.
Yeah. Very good. Thank you. Okay, so now if you could show us maybe a positional toolpath, so use one of the holes, and then a wrapped toolpath. We could explain how that works. And then the specific question is to show the new 4-axis surfacing, which we'll need a different part for. But I think
Yeah,
one of each one of those 3 examples would be good based on the feedback I'm seeing.
cool. So first, let's do an axial toolpath. So I'm going to rough out these spaces right here with an end mill. Probably need a long one to do that. I hope there's one already in the library. So let's use 2D adaptive. And the Z orientation is what's important when you're doing mill turn toolpaths. So as long as the Z orientation is pointing in the correct direction, you can apply your toolpaths normally. So let's pull up what tools do I have here. So I've got a long roughing end mill. Perfect. Okay, you can see the tools facing in the right direction. I will select a contour and a stock area. Okay, and there's a milling toolpath. And as long as you have a milling, an axial milling tool installed on your machine, the post will configure it to use either polar coordinates or XY coordinates or XC coordinates. And there's ways to change the output based on what machine.
Can you do me a favor? I'm distracting you again, but I think it's worthwhile. Add a finish pass and then do a pattern and show how we can order by operation.
Yeah. Okay, so I'm going to derive a 2D contour out of that 2D adaptive toolpath. No stock to leave. That's good. Okay, so there's the finishing strategy. Now I'm going to highlight both of those, add to new pattern, select circular pattern, select this face as the axis, and I think I need 6 instances. And then I can set the order for how to organize these operations. So I can order by operation, so it'll rough everything and then finish everything. Because I'm only using one tool, order by operation and order by tool are going to result in the same ordering. But if I choose preserve order, it's going to rough finish, rough finish, rough finish. So using the patterns is pretty good in this instance.
It's
and actually,
kind of a teaser, but I think we'll do a specific webinar on patterning.
Yeah, I'd really love to do a webinar on patterning. So the next thing I want to do is an axial toolpath. I mean, a radial, sorry. And it looks like we could either do the pockets on the side here, or we could also do these drilled holes. And
Let's do the pockets on the side so you can explain, because with 2D there's a couple different radial fields and each of them matter.
Yeah. Okay, so let's do a 2D pocket. And I believe there's going to be, I was looking for a 3/8 tool, but I think this 1/2-inch tool will still work. Yeah. And in this instance, I need to select an orientation for the tool. So I'll turn on tool orientation. Now I need to pick something to be normal to. I could be normal to this plane, but I don't know for sure if this plane is parallel to the orientation of these pockets. But these pockets have these edges on them. And I believe I can select one of these edges. Yep. And then my Z-axis will point parallel to that edge. And it looks like I just need to flip it. And now I've got my orientation set for that pocket based on that edge. So now I can select the geometry. The preview is a little wonky, but that's exactly what I wanted. And let's hit OK and see what I get. I got nothing. Probably because I have this stock to leave set too high. So I'll turn off the stock to leave. And I'm going through I know exactly what to change to, get this to work sometimes, just from experience. But what I'm doing is I think the lead parameters are too big for the tool to fit. It's possible that slot's even a half-inch wide, so I might select a smaller tool because I selected the
That
half-inch.
said, I think it's still good to work through this problem.
Yeah. So what I'm doing is first I turned off the stock to leave so that the tool has somewhere to go. But also this minimum ramp diameter was set to 475, which means that the diameter of the toolpath has to be almost half an inch. So if I set this to something small like 50 thousandths, it should just give me something, which it still didn't. So instead of trying to keep going with that tool, I'm going to select a smaller one.
While he's selecting the smaller tool, I think it is important to know about that minimum diameter. So when you're helixing in, there's a number that says what's the tightest helix that you can do. Just so you know, if you put in 10 thou, so that you just saw that helix that was just there, if you put in a super small number, we're still going to use the largest one possible.
Yeah.
And we're just setting a range between the smallest and the largest possible helix diameter.
Yeah.
So that was a radial toolpath that was positional. Can you now do the wrap toolpath on the pocket?
Yes. So, oh, by the way, I figured out the problem. It's because this slot is smaller than a half inch.
Yeah.
So half inch tool never would have fit.
Tool didn't. By the way, another quick trip. Select that face. Exit your operation. Select the face. Look down in the bottom right corner. A lot of people miss that, but it's a quick heads up measure command.
Yeah.
And my apologies, by the way, to the question on 4-axis surfacing. We'll get there. I think we're going to push past the hour, but we will get there.
Yeah. All right. So the 4-axis wrap. And also, by the way, you can pattern radial toolpaths. So do a quick one here. Circular, select the axis, and I want 4 instances of this. All right. So now you got 4 pockets wrapped around there. Actually, those are mirrored, so that was wrong anyway. Let's just back out of that. Pretend it never happened.
CJ goofed up.
Yeah, I did. Okay, so wrap toolpath for these walls here. Those aren't pockets that were created from one orientation. It looks like you need to use a 4th-axis toolpath to do that. So in 2D Pocket, in the Geometry tab, I'll turn on the wrap toolpath checkbox, and it's asking me for a cylinder. And what you want to do is you want to select a cylindrical face, and you also want to select the contour on the same face. And there's a good reason for that. This offset helps you in case you need to select a different cylinder than the contour selection. But with a 4th-axis toolpath like this, when the tool is always pointing at the center of rotation, the geometry is only technically correct at the contour that you've selected. Above and below, you might have material that is, you might have removed a little more material, or a little material might have been left on. But that's how you would get a wrapped toolpath. And I can simulate that, and you'll be able to see the tool tilting. That's a pretty easy one.
Okay, so let's go from there. And can you model something up that requires the 4-axis surfacing? It's in the extension, so I'm glad we kind of ended with this. I'd like you to show how to turn the extension on, and just when you open. So let's start with that. Just show the extension dialog, the wrench up in the top right corner there.
Yeah. So
with that, in CJ's case, it says axis purchased. Of course, he's an Autodesk employee, and didn't have to. For any of you on the call, just as a reminder, we let everybody know in the what's new. But through the duration of the world being in disorder with COVID, I think all of you know that the trials of Fusion have been extended, but also access to the extension, which is normally an additional fee, is also free for everybody. So you can turn this on and try it. I think right now it's somewhere until the end of May is the current thinking. If you've already purchased it, just know when your purchase time runs out, then you'll be able to extend it at no charge. So certainly encourage you to do that. With that, inside of the latest update, we added 4-axis surfacing. So I'll get CJ to show that. While you're still here, scroll down to 4-axis surfacing, and I'll give a shameless plug to, the rotary strategy is what it is. There's a learn more. Click that, and you're going to get some more information on how to use it. But with that, CJ, let's show how to use the rotary toolpath.
CAM sample part for that, or should I just draw one?
Just draw something up.
Okay.
Doesn't you could extrude an ellipse for all that it matters for the purpose of this.
Yeah. Okay. So let's start a sketch here. I'm going to do that. Ellipse. That's fine. It's going to be a big ellipse. And let's also draft it. That looks too much like a circle. Hold on. Let's, there we go. Perfect. Create a setup on that. So in this case, there is no nice axial selection on the part, but you should be able to select the axis from the origin there. So as long as you have the origin showing, you could select an axis off of that.
I mean, honestly, if you're doing this as a 4th axis, the z-axis would be pointing straight up anyway. Your rotary axis is probably X.
And over to milling, multi-axis rotary. And I will make a ball and mill. That's fine. It just happen to be the defaults. I get something that looks like this. And let's just hit OK and see what we get. Because we should get something. Cool. So we can apply some boundary containment so that it's starting on the part instead of on the air like that. But pretty darn easy to get a 4th axis wrap toolpath now.
And then I think maybe what's worth showing is you can have an offset angle so you're not cutting with the tip of the ball. It's probably worth showing, and then you can change what direction it moves along.
Yeah, so this tool offset parameter here sets the tool off from the center of rotation, as I said, so you're not cutting with the very tip of the tool.
So let's just do something somewhat aggressive to give an example of that. I think we can show that. And then maybe try your...
and what was the other thing you wanted to show?
Geometry containment. Let's just move those planes in.
Yeah, okay. So instead of stock front, I want to do model front. I don't need any angular limits because we're going all the way around the part, but you could set, I only want to do 0 to 90 or something like that.
Yeah.
And let's view it from the front here. Okay, so now you can see that the tool either will lead or drag so that it's not cutting with the tip. In this case, it is leading.
Yeah. And the reason the toolpath looks like it's coming off the part is obviously we're driving along the center point of the tool, but it's the contact point of the tool that's actually along the model.
Right.
Well, we got a wow.
This is an easy toolpath to use. It's pretty cool.
Yeah. So again, strongly encourage you. I'm glad the question was asked because it's a great time to try it out. It's accessible to everybody. Again, just show that wrench again. I don't want to make this a sales pitch by any means, but I'm telling you how to get access to stuff for free for the time being. Doesn't matter how you purchased your base Fusion. These extensions are accessible to you. Because CJ's already got it, it shows access purchased, and in your cases, it'll show access granted. But yeah, with that, any other thematic questions to go along?
Were there any that we were waiting to answer that we didn't get to?
I'm just going to scroll through them quickly. Maybe you take a look as well. While I'm scrolling through the questions, I'd love to hear where everybody's from. I saw somebody from Belgium. I know some names on here that are from Australia. I'm just playing. He's from New Zealand.
Also, if anyone has any comments about, we barely scratched the surface on a lot of these turning operations, right? Just to kind of gloss over and see what's there. If you want to see something specific, I can do that in a future live stream. And we can spend a whole hour on just one toolpath. Maybe it won't be the most interesting, but you'll get a lot out of it.
Some people liking the CAM samples. I'm glad you like the CAM samples. Personally, I do too. I learned most of my stuff by reverse engineering what other people did. So I'm glad there's others like me. Most of us machinists learn by doing and seeing how other people did things. So Sweden, North Carolina, Canada, Florida, it's all over the place. All right, I don't think I missed any questions. If you asked a question and got lost in the chat, maybe just re-ask it.
Yeah, re-ask it in the YouTube comments in the video. We look at the comments.
Yeah. Maybe the other question is just we look at the comments. The pace of this one, similar content like this, would you have liked us to go faster? Were the distractions annoying to you or positive to you? Again, I'm just curious. This hour is for you. It's our chance where we're traveling less as product managers. So trying to make positive use of the time and give this hour to the users. So if this was useful to you, great. If there's better ways you can make use of us as product managers, we're happy to, but genuinely want to get feedback. I see some questions around doing some G-code ones. Love to know if there's interest around your patterning idea.
Yeah, I think patterns is it's kind of one of those hidden things that not a lot, especially with our component pattern, not a whole lot of other CAM systems can do.
Yeah.
So
let's do that. Let's do patterns next week.
Okay.
We can G-code and post-processing. Maybe what we should do is have George or one of the other PMs join us on the week that we do post-processing. It might be fun.
Yeah, sure.
Good. Well, for everybody then, I see some people in Europe, so thank you so much for choosing to spend your Friday evening with us. For the people in Florida, I guess your Friday's just starting, and for CJ and I on the West Coast, we have a couple hours left for our weekend to start, but I hope everybody's staying healthy and enjoying the time with your close family. See you next week.
Thank you.